All right. Hi everyone. I've just sent a broadcast out, and we've got a few people coming in now. We'll just give it a bit of time to allow some more people to come on before we get started. So just bear with me for a few more seconds, and then we'll get it going. In the meantime, grab yourself some lunch if you haven't already done so, a drink of water, and can I also request those who are coming in to turn your microphone off so we don't get any feedback. Just letting you know that this is being recorded and it will be available to you at the end of the seminar in a couple of days' time. All right, so we've got a fair few people coming in now, which is wonderful. Apologies for any glitches with being able to log on. We're just trying to figure out why that has been the case, and I'm sure we'll get it fixed for next time. So yes, before we begin, again, welcome again to those who are still coming in. I hope you're all well today with everything that's going on. So just to give you a bit of, before we get into it, I just want to let you all know that with the response to everything that's happening with the current COVID-19 situation, and to ensure the well-being of our team members and the wider community, we'll be bringing all of our events to you online like this through Zoom in the next couple of months. So you would have got perhaps some cancellation messages for anyone who's registered for in-person events, but please just keep posted and aware of what's going on. Also, if you could email me at kylie.barringer@acs.org.au with any key topics you'd like us to touch on in the future, particularly around business continuity in the tech sector, which we will be delivering more on the next couple of weeks. And just make sure that you visit our website to keep up to date with the regular events that we're having, and also on our Facebook page where we put up our events that are current. Speaking of that, on the 16th of April, we have an event, a webinar at 12 noon, again, Queensland time, which is very topical as in the climate that we're in. The topic is on strategies for leading and managing remote tech teams. So if you're in that situation, or if you want to understand a bit more about the best practices with that, please come into that, register for that webinar. You can register online for that. We also have on the 22nd of April at 5:30 p.m. a webinar on trends and opportunities in the local Gold Coast tech sector. And we also have more events coming up in April as well. They're already up there, and May and June, a couple more to come. All right, so without further ado, I will hand over to our wonderful Paul Comer. Thanks, Paul, for presenting for us today. Paul is a digital coach and trainer with ALC Training. He has a myriad of years of experience and very, very knowledgeable in every aspect of tech. So, Paul, thanks again, and I'll hand over to you. I'm going to go offline now. I'll be here, but I'll just won't be visual, or my microphone won't be on. So we will answer any questions as they come through. If you have any questions, can you please put them down in the Q&A or in the chat section, please, and we'll address them as they come. Enjoy, and thanks, Paul.
Thank you so much, Kylie, and thank you to the Australian Computer Society for allowing me to let you loose on you all. And thank you for you guys for taking the time to spend 45 minutes, 50 minutes with me, talking through a little bit about the DevOps global best practices, and to see a little bit of a demo of some Azure DevOps in action. So thank you, guys. Most important thing is I have my hand sanitizer already, so I hope you guys do too. Without further ado, let's get moving. So pretty much the first slide that you see is our link to the DevOps Foundation course. So we're showing you a bit of a snippet of that, and there's a little discount code underneath. The most important thing is the DevOps Institute are the company behind the syllabus for the foundation, and we're going to give you a little bit of a taster today. So let's keep moving. So a little bit about me. I'll keep this very short. As Kylie said, I'm a trainer and a digital coach with ALC Training. Previous to that, I was a solution architect, specializing in cloud with DXC technology. I was with them for about 12 years. I also do a bit of volunteering from time to time with the State of Emergency Service, which keeps me pretty busy. The picture you see there is of the G20 summit. I also started off my life as a musician, so a lot of the prototyping, a lot of the agile and DevOps techniques that we use in tech we've been doing in music for quite a bit of time, actually. And finally, I've been doing stand-up comedy for the last 13 months. Something a bit different, and that sort of complements the training. So we'll keep moving, guys. So first question everyone asks is what is DevOps? So let's talk about where DevOps really started. So we started off with a challenge in really the IT sector. The challenge that we had was that we realized that developers and operations weren't working together as closely as they should be. Dev includes all the people involved in developing software products. So we don't just mean developers, we mean the architects, we mean the business representatives, customers, product managers, project managers, and so on, as you can see in the slide in front of you. The ops side of things includes people like information security professionals, system engineers, system administrators, all the people that help run the actual service. That includes things like change configuration, incident management as well. So really DevOps is very much a cultural movement, allowing not just Dev and Ops to work closer together, but we can actually apply those principles across the entire business. We actually want all of our business units to work closer together and to collaborate. One of the biggest challenges we have in business is generally each department is funded via a cost center type model. Certainly we see that in medium and large corporations that have been around for many, many years. The new paradigm, certainly in the startup era, in the agile era, in the era of DevOps, is for companies to restructure the way they fund themselves according to a value stream. So let me quickly define value stream. There are really two types of value stream. There are business value streams and there are development value streams. Business value streams are how do we acquire our client all the way through to how do we deliver a product or a service. They consider of a series of stages, usually no more than 9. We then also have a development value stream, and this is effectively our continuous integration and continuous delivery pipeline. So how do we release value, that's artifacts and software, to meet client outcomes for each system that supports the business value stream. We cover that in a lot more in detail in the course, but that's just a bit of a primer for you guys. So the important point here is that DevOps extends beyond software developers and IP operations and is a series of cultural concepts as well as a series of tooling and automation practices that we can apply to the entire business. So the key takeaway is that things like automation are not just for technical people. Automating our processes and automating what we do is for everybody in the business. Does that make sense? Good. We're going to move to DevOps values, but before we do that, Kylie, do we have any questions that we need to address? Maybe a couple of questions you could throw at me, if you're still there.
Yeah, sorry, just unmuting. No questions just yet, Paul. Keep going.
So feel free to keep those questions warming up. So let's talk about DevOps values. So like I said, DevOps is very much about a cultural movement. So culture is number one. It's really about people. It's about having the right people with the right skills, working on the right types of work. That's very, very important. Automation is important. Culture is important, but automation is important too. We want everybody to think about how we can remove the mundane task from our developers and operations people initially, but also from other areas of the business, and think about how we can automate those things. How can we move our people to work on the more important, the more valuable items? You know, certainly in my context, the most valuable thing that I do is I work and deal with people, either face-to-face in the classroom, but more recently, obviously with the COVID-19, we've been doing and that's something we're really, really cultivating. So again, automation, very important. Lean is all about removing sources of waste. So when we mean sources of waste, we mean things around how do we communicate more efficiently? Is it better to send a complicated request via email and then risking that we at in maybe 20 people and risking the email bouncing around our email system for 2 or 3 days? Or is it more effective maybe to have a meeting to discuss that complex issue? Or maybe we can make a series of phone calls to resolve that issue. So again, lean is about removing waste, and the communication is a big part of that. Other sources of waste tend to include things like waiting time. We can use a technique called value stream mapping, which allows us to identify where we might have things sitting in queue. So for example, if we're acquiring a customer all the way through delivering a product or service, are there any significant delays in that chain that we can remove? Measurement is about understanding that as we perform our experiments, so we perform DevOps experiments, that we know if we measure before and after, we know whether we've got value, because we can see that in the measurement. So one example that we might use to measure, for example, might be how quickly are we burning through stories in an agile development practice. We might apply, for example, a particular experiment where we add another resource to a team. We measure before we add the resource, we measure after, and do we see the net effect of, for example, those stories accelerating? Another technique we might look at is implementing a work in process or work in progress limits. So this limits the amount of work that a particular team or a part of a team will work on. So we can put a WIP limit after we've measured to see if we get the desired effect of increasing the flow through the CI/CD pipeline of that work and seeing an ultimate return on value. In other words, an increase in value. Sharing, we've already talked about a little bit. It's really around everybody collaborating. It's everyone having an open, transparent, trustful culture where we're all in this together. The COVID-19 is really the ultimate synergy of that. It's great to see all of the countries best as we can working together, and in Australia in particular, all of the states and territories working together. That really typifies the ultimate success with DevOps. When we all work together seamlessly, we produce fantastic results. So just to summarize, more than anything else, DevOps is a cultural movement based on primarily human, but also the technical side of things are important. We want the human and the technical to come together to improve relationships and results. Next slide. So we've talked a little bit about what DevOps is. Let's just clarify what it's not. It's definitely not a title. It's not something we should see when we advertise. It's not a job title, although if you go onto Seek, if you go onto LinkedIn, there'll be plenty of DevOps engineers, but it's not really, you're missing the point if you think DevOps is a thing. It's not a separate team. It's really about all the teams coming together. It's not a tool. Tooling is important, but what's more important are the people that you have, the skills that they have, the experience they bring to the table. And ultimately, when those things are in place, then the tooling then can accelerate those great things that you have about your people. It's definitely not about only culture, but culture is important. We need tooling in order to accelerate that success of culture. It's definitely not just about automation either. Automation's important, but it's certainly not the be end and end all. If we don't have a positive, what we call generative culture, so a generative culture, as defined by Western, again, we cover this on the course, is all about empowering people to be the best that they can be, to implement their ideas, to empower people, to inspire people, as opposed to a bureaucratic or pathological culture which stops all that. Effectively, a generative culture is what we're trying to aim for in DevOps, and that's what produces the best results. It gets the best out of resources, best out of people, best out of information, ultimately provide the best value to clients. It's definitely not anarchy either. I'll just pause there, guys. I just had an internet connection is unstable. My internet is usually pretty good here, but we'll keep rolling. It's definitely not anarchy. So that's important. We need, as we do in Agile, we need just enough structure. That's very, very important. We don't want to overplan. We don't want to do big upfront design, but we do need to think about what we're going to do. We need to spend a few hours, possibly a day or two, to think about how we're going to move forward and do a little bit of planning. We want just enough planning so that we can execute, say, for the next few sprints. Scaled Agile in particular is one framework that I love to reference. The way that framework works, it works for medium and large organizations. So particularly if you're running, say, resources of more than 100, it's very, very great framework to use. What we recommend in Scaled Agile is that we do 2 days of face-to-face planning. That could be virtual as well. So sets of people in different locations, all connected video conference over 2 days. And then we spend those 2 days planning purely the next 50. So over the next 50 days, that's 5 sprints. What top 10 features can we progress? And we spend the 2 days breaking those things down into story. The Scaled Agile framework is an example of one such framework that DevOps culture will pull in. Other important frameworks that we utilize in DevOps culture are the ITIL framework and also the TOGAF framework, which is an architecture framework. So I believe we need all 3 of those things to come together to really give us success. We also pull in the practices of lean manufacturing. That's all around reducing waste. And we see those things come in when we're looking at process improvement, when we're looking at reducing waiting times, those types of things. Most importantly, as I just illustrated there, we have these different frameworks that we should really pull in. DevOps, it really depends on the talent that you have working for you. It does depend on your culture. It depends on what you're doing and the context of the business. All these things can be shaped in different ways and provide different sets of value to yourselves and clients. So there is no magic sauce. There's no silver bullet. It's really bringing all these frameworks and cultural change together into this melting pot using a series of practices. And so once we get through the definition of DevOps, we're going to run through some typical software development practices. Cool. Just to recap, we'll do a quick summary and I'll see if we've got any questions lined up. DevOps is an experience-based cultural movement. It's constantly being proved by and shaped by practitioners. That's all you guys. So that's both technical people, say in the development space and the operations space, but also people in the C-suite. Leaders play a huge role. We do need transformational leaders in DevOps. We can look at examples of some fantastic companies like SpaceX and Tesla who are using a range of agile, lean, and DevOps type practices to gain incredible value for clients. So Elon Musk, NASA, for example, used to launch rockets every 6 months. I think Elon Musk is currently on par to launch a rocket every 1 to 2, maybe 3 weeks. And he's been doing that consistently for 6 months. That requires, being able to put software updates more regularly and requires a DevOps culture. The important thing we've said is not a product, not a specification, not a job title, and very importantly, it's community-based. So like I said, all of you guys play a role in shaping DevOps and in shaping the best practice. It may be that I come up with a particular practice, maybe around continuous integration. I see someone else coming up with a better practice that works. I'm probably going to adopt that better practice and build on it. So it's about all of the best practices and improving them, and then sharing those best practices with everyone else so we can all improve together. Very important, it's open to everyone. Learning from each other, both within and more importantly, outside your organization is also a huge part of a DevOps culture. We are all lifelong learners. We can all learn from each other. Everybody has something to give in terms of learning and receive. And we need to be aware that probably most of the innovation that we want for our clients and want for our organization lives outside the company. So we need to think outside where we're working and bring in that innovation into where we work. Things like open source, things like tooling, things like cultural ideas. How do we solve this problem? All those types of IP and ideas should be coming into your organization. What you've got on the bottom of your screen there, you've got a beautiful web link there to something called the State of DevOps Report 2019. So if you're now itching to understand some of the benefits and some of the specific measures, you can have a look at that report. I'm just going to come out now and just do a quick screen share. So let me just share my web browser for you guys. Hopefully this doesn't break. Share away. Hopefully you guys can now see a web screen. I have a second screen here. This is the Accelerate State of DevOps 2019 report. Beautiful front cover. And what I'm going to do, let me just do a find here, just so I can find something quickly for you guys. I'm just going to look for the word elite. You'll see why in a moment. Basic exec summary at the top. Some information around how they've collected the data. But more importantly, they defined what elite, high performing, medium and low performing looks like in terms of 4 metrics, in terms of deployment frequency, in terms of lead time for changes. So that's effectively the waiting time plus the actual cycle or labor touch time. Time to restore service and change failure rates. They're the key metrics that we often focus on in a DevOps culture. There are obviously other metrics, but there's something to get you started. So feel free to download State of DevOps report, which will whet your appetite a bit further, hopefully. So do we have any questions?
Yep, Paul, we have about 5 related to skills and tools. I'm not sure if we should address it now because it might steer you away from where you want it to go. So we might just, is it okay if we just park them and we address them later? I think it'd be a good.
Absolutely, yeah, not a problem. Yeah. That's good. Let me just put those to one side. Awesome. So let me just share my screen back. We are going to there. That share, and now I'm just going to hit the good play time. So this is where it gets really exciting. So I'm going to talk about 3 specific practices. There's probably 15 or 20 specific or categorized practices we talk about in our course. I'm going to talk about 3 practices. Prior to that, though, I'm going to talk about the 3 ways. So the 3 ways are 3 habits, I guess, that everybody can think about and can develop. These 3 ways effectively are things that you can do or ways of thinking that lead to many of the Agile, DevOps, and Lean, and some of the ITSM practices. So for example, about Scrum, probably most of you, not all of you, have probably heard of Scrum. The key components of Scrum are, and let's talk specifically about the stand-ups, the daily stand-ups that we talk about in Scrum. There are 3 things that we do in a daily Scrum generally. What do we do since the last Scrum? What are we going to do today, or what we're going to do for the next Scrum? And most importantly, are there any barriers that each person, for example, the first question is that's alluding to the second way, that's feedback. You're explaining to your people on the team and yourself what you've accomplished, which gives you a sense of uplifting, gives you a sense of hope that you are moving forward. The second question is about the things that you're actively working on and gets you to think about how you might structure those things, but communicating that obviously to your peers helps reinforce that knowledge and that learning. And the third question is really, really important. Again, it's an example of a feedback loop. This is the second way. It indicates to the product owner and the Scrum Master and potentially the other teammates that there are impediments that you need removing. So generally it will be up to the Scrum Master and the product owner to work together to work through how they might then enact those or remove those barriers effectively. And that's an example of flow. So the first way is flow. Removing barriers will clearly speed up flow. So there's an example of a very common Agile practice, software development practice called Scrum. Specifically, it's daily stand-up. We take that into a DevOps culture and we think about in terms of the 3 ways. So let me just talk through those 3 ways just so you got those clear. So the first way is flow. In a very simple Dev and Ops concept, it's making sure that we understand and increase the flow of work. So as a developer, how do I receive work? How do I work through that work? And who do I hand that work off to? That's very important. In a value stream, we might have many people working in a software development practice. So we'd have developers, we'd have testers, we'd have environments we have to deploy to, we'd have Scrum Masters, product owners, we'd have a whole range of people that would form the basis of that team. And often if you're working on software products, you would have a team of teams. In Scaled Agile, we'll call that an Agile release train. So it's very important that everyone not only knows how they receive work, but who consumes their work, what that process looks like, how that process is visualized using a Kanban. That's very, very important. All work must be visualized. And more importantly, what part do they all play in the value stream? So the system that we're building, the features that we're building, how does that add value to the business? That's the first way. The second way is where we create short feedback loops that enable continuous improvement. So in the DevOps context, that's ensuring that the ops are feeding back information to dev. And in the bigger value stream space. I'll just pause it there. It came up with a warning that my internet connection was unstable, so I'm just going to give it a time to take a moment. We have those short feedback loops. Feedback loops can take many forms. Automated testing is an example of a feedback loop, because instead of waiting, say, 8 weeks for a manual build, I can press the button. Within an hour, I get a feedback loop to tell me that my code that I've released has worked because it's passed all my automated tests and the build has been successful. My last role at DXC, I was lucky enough to work on an offering called My Work Style, where we employed all these cultural principles. And I had a team of architects, engineers, and developers all working with me to deploy effectively a Office 365 private cloud offering. Much, much smaller than Office 365, but we had major clients that we deployed those to. So they formed the top ASX 100, basically. And so it was important for us to get feedback quickly. So we took a journey of automating everything. And so that's an example of feedback loop. Logs, dashboards, analytics are all examples of feedback loops. Prototyping things is a feedback loop. The key with feedback loops, we call them often. A feedback loop is a learning opportunity. That's really, really important. It's an opportunity to understand that whatever we've done, how close are we to what the client or the person that we're delivering value for, what they want. The only way we're going to know is to show them something and to ask them some questions. If we leave it too long, for example, if we go away and we work on a feature for 10 days and don't have some form of feedback loop, if the 10 days we have deviated from what the client wants, and I guarantee you will if you don't have the feedback loops, that's 10 days of work you have to fix. If you're able to get that feedback within 1 day, it's only 1 day of risk or mitigation you have to fix. So it's very important to have those short feedback loops, which is why in Scaled Agile, we recommend system demos to the entire team every 10 days and every 50 days demos to the business owners. I would also suggest that once you start running after 50 days and you start improving as you do your system demos every 10 days, you involve the business at the same time. Good. That's the third way, and this is probably the hardest to practice. It does require leadership buy-in, but we want to create a culture that fosters two things. We want to foster a culture of experimentation, taking risks, and learning from failure. This is really, really important. If we fail to experiment, if we stay in the same patterns that we constantly do every day, nothing changes. You'll get the same result. So one of the important things with experimentation is it allows you to show you that you can gain a different result. Once you've measured the before and after that result, you can then ascertain whether that's improved what you do or whether it's detracted. The law of probability states that every experiment is not going to be 100% successful. Some of the experiments are not going to work, are not going to fail, but they're not wasted. They're learning opportunities, and that's really, really important. So every experiment that we do that we realize has a shortcoming, there is a learning from that. It's just like my stand-up comedy. If I say a piece of material and no one laughs, I've got a range of things I need to think about. Did I deliver the material correctly? Was it written correctly? Was the audience in the right frame of mind? Did I set up the approach, the setup correctly? There's a range of things, and I can try that 3 or 4 times, try and improve each time. And generally after 3 attempts, if no one's laughing, I usually scrap the material and go, it wasn't funny, and move on. And that's how I approach comedy. You guys can do exactly the same with your software experiments. There might be a new feature or function that you want to take care of or have a look at within, say, Java or C# that might improve the outcomes that you had last time. You need some time to experiment, and that requires leadership to give you that time. The other important thing is that when we embark on a piece of work, typically a piece of work will have a number of unknowns. It will vary, probably from 10% to 30 or 40%. Reducing unknowns, and that needs to be scoped as well into our work. Secondly, we want to understand that repetition and practice is the prerequisite to mastery. So what do we mean by that? What we mean is that practicing something for a little time, maybe 10 or 20 minutes every single day, will lead to being really good at something or mastering much quicker than maybe spending 2 hours once a week. There are plenty of examples where this works. So you probably noticed I'm a bit of a muso. So years ago, I used to practice a lot on my musical instrument. I used to spend about half an hour to an hour a day of practice, quite a bit more than probably most of you would. But as a professional muso, you know, you have to keep on top of your instrument. But I used to practice an hour a day, so that's in my context little and often. And over a period of time, you learn pieces of music very, very quickly. Other contexts you can apply that to are special forces. When you're training for sport, you tend to train little and often. Martial arts is a good one. When you're doing something called a kata, which is just a sequence of moves. That's a small sequence of moves. You practice it over and over and over again to get really, really good. So lots of other industries and other areas, probably hobbies that you have where you can apply these techniques. So that's the three ways. The first way is flow. Second way is feedback. Third way is continuous experimentation and learning. So these are things you guys can take away and have a go. I'm going to move into this way. Of course, we cover more detail the other ways, but I'm going to just focus a little bit more on the first way. We're about halfway through, guys, so 12:30. We've got a few more slides to go, and then we will get to the demo, I promise. Everyone's, I know, hanging for the demo. So the first way, I had the unstable message again, so I'll just pause, let things recover. So the first way is flow. So like I said, understanding how you consume work, but more importantly, who consumes your work and how that process works. We want to increase that flow by removing constraints. So constraints might be stress. If people are stressed, we might want to think about how we might help them cope with stress. There's obviously training and things that we can do there. It may be simply they have too much work and they're not able to prioritize. So again, we can remove some of those constraints. Maybe the person who's trying to develop the code is stuck in meetings all day. So again, that's a potential constraint that could be moved. So we want to understand that flow by understanding and removing. Never pass a known defect downstream. Why is that? Because every single defect that we pass downstream generally becomes a much higher risk the further down the value stream it goes. And eventually it will end up in production. Eventually it will end up as a defect that the client either sees or feels because there's a deficiency. So with known defects, we want to fix them all. The challenge with not fixing those known defects is it contributes to what we call technical debt. And as we all know, once something goes to production, it generally doesn't get fixed until something really bad happens. All those defects that go into a system, we want to remove. And that provides us with the best quality of service that we can, and also arrest some of our technical debt. Never allowing local optimization to cause global degradation. Very simply, if I do something that benefits me, but it does not benefit the entire team or the value stream that I'm working in, then I won't do that. The only way I can know whether a change to what I'm doing or anybody else does in the value stream is beneficial for the entire value stream is by measuring it. And so that's really important. So we don't want to sub-optimize for each other. We want to make the entire process more efficient. So we need to test people. That's very, very important. So just because I do something that's beneficial for me, if it doesn't benefit me, benefit the value stream, and ultimately the client, we shouldn't do that. Makes sense? Good. And finally, this is what architects usually are generally very good at doing, achieving a profound understanding of the entire system. Well, I guess it depends which architects and where they're based and which companies. I guess a bit of a general statement there, but certainly one of the aims for me as a cloud architect in my previous role was to really understand the entire system. System being people, process, and technology. So not just technology, but people and process. So how are people visualizing work? How is work progressing through the Kanban? How are the commits going? Are they smooth? Are we receiving a high number of defects? Are there tests that we can automate? A whole range of things. So a goal of the first way is to have the work flow quickly from left to right, not just from dev to ops, but across the entire CI/CD pipeline. And anyone that's worked with CI/CD tools knows they're built to automate and to improve that flow. Awesome. Let me move on to some practices. So I've got three, let's have a look. I've got three practices here. I've got continuous testing, continuous integration, and continuous delivery. And then I promise we will get to the the demo. It will only be a short demo. I'm just going to show you some of the key features and talk about some of the key concepts that we've talked through. So very quickly, how are we doing? So my aim was to run the slides for about 5 more minutes and then we can get to the demo. Continuous testing is the process of executing automated tests as part of the deployment pipeline so that we can obtain immediate feedback on the business risk. We only know if there's a business risk if we have tests that tell us there's a defect or deficiency. We can then have an assessment of that risk, either subjectively within our teams or with the business, and assess whether we need to do something different. Like I said, it's very important that any defects that we find, we fix. There are a number of different, if you like, sub-practices within continuous testing. There is test-driven development. The best resource I find for test-driven development is the scaledagileFramework.com website. The top right is a little magnifying glass. You can type the words test-driven development and there'll be a beautiful article that comes up that shows you some of the things to consider. Very briefly, test-driven development is when we empower our developers to write the test first, watch the test fail, write the code then that we need to complete the story or the feature, and then watch that test pass. In reality, we don't necessarily do it quite in that waterfall way. It's really a feedback loop between the testing component and the code component with the developer. What's really important with that practice, though, is that all code is peer reviewed so that the tests aren't rigged. Ideally, in better practice would be to have programmers in pairs working on the coding and the testing together. Another pattern you might see as well that's highly encouraged from a security point of view, and we cover this in our DevSecOps engineering course, 2 days, is that we want to write code that is well structured, commented, so that not only is it easy for other developers to understand, but also our semi-technical resources such as security, cybersecurity engineers can look at the code and gain a sense of, I guess, understanding and knowledge that there's no malware in that code. The important part about review, it does 2 things. It improves quality, but most importantly, it shares knowledge. So by making sure everything is peer reviewed, we don't have any points of understand what's going on. And by having security coming and doing maybe spot reviews on some of the code, it's got an unstable internet connection there, so I'll give it a moment to recover. By bringing the security people in early, we're empowering them to certainly get confidence that our code is really well written and it's secure. So that's another important practice. Also, the security people as well get knowledge of what's happening with the code. Performance testing is still very important, so performing things like load testing, even on non-production. So my sort of view and the best practice seems to be emerging that we generally want to apply the same level of security rigor to both our production and our non-production instances. The reason for that is because if I'm a hacker and I can compromise a system, it probably doesn't matter whether production or non-production. I'm going to get in and see what data I can see. Because often in non-production, we might have some production data. It's true, it might be masked or might be, some of the sensitive data might be removed, but there might still be value in some of that data. So best practice I always recommend is the same level of security controls on both non-production and production. That can be a bit contentious because people will talk about cost. But to be honest, when you're looking at cybersecurity, you want to keep everything as secure as possible. We've got end-to-end use case testing too, which can be automated. We've got security testing, which can be performed by application security testing tools. We talk about DAST and SAST types of testing in our DevSecOps engineering. We'll keep moving. I won't cover those here unless someone really wants to know a little bit more about that in the questioning. The manual testing, of course, we want to keep to a minimum, but we do need manual testing. Things like user experience testing is often manual. We've got canary testing as well. So if you're familiar with the canary in the coal mine analogy, very briefly, coal mines, when you mine coal, there's a risk of releasing methane in underground mines in particular. Methane, when it's natural, is completely odorless. So the idea of having the canary, poor canary, in the coal mine is that when the canary falls off the perch, everyone evacuates because there's likely to be a methane leak. And so when we apply it to software testing, we basically mean a canary, a pilot test, a little experiment effectively. Blue-green deployment, our users are on the blue deployment, and we're then updating our green deployment with the latest release. And then we move our users across from one production to the other slowly, and then we eventually retire the blue, spin up a brand new blue with the next release, and then we do the same backwards. The idea of moving users slowly to a new release is that we limit what we call the blast radius. It's a very common DevOps practice that you'll be familiar with if you're worked in Amazon or worked in Google or worked in Netflix. They're common techniques, and Microsoft too, common techniques they will use to limit what we call the blast radius. Spotify is another great company. So there's a great video you can look out for. Just Google this, Spotify Engineering Part 1 and Spotify Engineering Part 2. 10-minute videos. They give an insight in what Spotify are doing from an Agile and DevOps perspective. I'm giving away all my secrets. We show all these videos on the course, but oh well. Yeah, there we go. Left-hand side, you've got functional and non-functional. If you're familiar with IT, nothing changes there. Shifting left is about building quality into the software development process. So we want to generally shift left and include our security people early. And over time, we want to include our tooling and our automation in the security space left. We also want to bring in our test automation and shift left. In fact, we want to automate everything, and that's called shifting left. Integration is a development practice that requires developers to commit code into a shared repository at least daily. So a shared repository is a GitHub, a Git, some form of repo. Ideally, the best practice is for everyone to be working on the single master branch. That way, when we commit our code, so we might have a number of developers writing code, we're committing it daily, we're seeing any integration issues instantly. What's important though is you probably keep your previous version. This is what we used to do with my work style. A previous version, a stable version of your on separate branch. So I tend to have separate version branches, and that's the way we did that at DXC Technology. But very important that we'll all work on the same master branch. There are some other patterns I've seen people working on separated feature branches and then merging, if you like, everything from the default branch into the feature, and then eventually merging it back into the main branch. Yeah, it's another way of doing it, but have a think about whether you can move to a single branch. Again, do an experiment. Try your separate feature branches with one team. Try a single main branch with another team, ensuring they're all integrating daily, and just see which one works for you. As with all these techniques, it's important that you find value yourselves. You do an experiment, you see if it works for you. If it doesn't, you tweak it. It will depend on your culture on what you do. That's the best practice that we sort of aspire to. A check-in is validated by an automated build and a series of tests that will pass. So committing code is not a successful check-in. A successful check-in is when we have a perfectly good, stable build that's passed all the tests. That's one checking, and we want to try and do that every day, and every developer aspires to do that. Some days we might not get one every day. We might find every 2 or 3 days. Again, it's about improving and about seeing how we can all work together. The most important thing is you're getting improvements, you're getting wins. You're seeing the right features being developed for the business, and you're seeing those features being developed and the stories being developed in a faster and faster way. So it's important to measure velocity as you go. It does require consistent coding standards. We alluded to before around commenting code and making sure everyone agrees to what good code should look like. Obviously, it's language dependent. We also want to be cognizant as well of the OWASP top 10. So that's the top web application security vulnerabilities that can appear in a number of different languages. Things like cross-site scripting. So that's part of the role of security testing and the automated security tests that we want to run to try and pick up any OWASP top 10 vulnerabilities that we might find, for example, cross-site scripting in JavaScript, for example. We do need a version control repository, so GitHub. We need a CI server, so a good example of a free open source CI server. I want to say free, I mean the licensing's free. Obviously, nothing's really free in this world. Is Jenkins. What I'm going to show you when we get to the Azure DevOps, which we'll get to in a moment, I'll show you these different components and I'll talk about the open source equivalents. Important to run on production-like environments, and it provides us with early detection and quick remediation. Continuous delivery really takes things to the next level, making sure that our code is always in a releasable state. That means if we decouple our commit, our successful builds, if you like, improving and working through our stories and decouple them from the feature release, it means we can gear ourselves to release at any time. So that's important. Ideally, we really want to release reasonably regularly, but if we want to, we might, for business reasons, want to batch up a number of successful commits and maybe release once a week. Maybe because the end users don't want too much change, or maybe the culture doesn't allow, or maybe there's some other reason. But again, it takes it to the next level, and it's another important practice. So, Kylie, should we do the questions now and keep, or should we go into the demo? How do you want to run things? What do you think?
Well, how long is the demo for?
It's only about probably 10 minutes.
10 minutes.
Yeah.
Let's get to the questions and then run the demo at the end and then come back in. Is that okay? Because we've got about 8, and I think there's some good ones we need to touch on.
Yes. Okay.
So I'll start with the first one we got in. It's from Elizabeth. Hi, thanks, Elizabeth. Question is, which are the go-to DevOps tools?
Okay, great question. So it depends where you are on your maturity curve. So some of the most common tools that I've seen, and you'll all nod your head, is for backlog items. So that's for tracking your work, is Jira. Atlassian Jira is the most common. For continuous integration, the most common I've seen is Jenkins. The most common I've seen for source code repository is enterprise GitHub, or public-facing GitHub, depending on whether you're a small provider, might be more open source, or you might be a large company like DXC. We have our own enterprise GitHub, which is basically a private cloud-hosted version. In terms of automated testing, we've got Selenium and Cucumber seem to be most popular. Other products that I've seen that are very good as well, that are in use across the different courses I run. Team City is another one. What else do we have? In terms of security tooling, it varies, but certainly for analytics, Splunk is a very common tool. What else do we have? Some of the open source tools as well. So there's an OWASP dependency checker, which I think sits in the SAST and DAST space. So the OWASP top 10 is some open source tools. What else? That's probably most I can think of. And what I'm going to show you with the Azure DevOps is basically all those open source tools, all lovely integrated together to provide you with a seamless way of getting started really quickly. So you can choose your own tools, or you could get started with Azure DevOps. And that's why I do the demo on that, just because it's easy to show and it shows you all the components you need to get started. It also has plugins as well. Hopefully that answers the question, Elizabeth. Thank you so much.
All right, we'll go down to, just bearing in mind, we may not be able to answer all of your questions today due to time, but I will send a list of questions to Paul that's come through, and I'll get him to answer them, and then I'll send it all to you along with your points, confirmation, etc. like that. But I would like to touch on this question. Hi, Paul. Thank you for your awesome sharing. I may have a silly question, but can you please summarize the responsibility of DevOps in one sentence? That's from Steve.
One sentence, okay. Thanks, Steve. First of all, no such thing as a silly question. Especially when I run courses, the only silly question is the one you don't ask. So you asked it, so we're good. But basically, shared responsibility. It's probably not what you're going to hear, but what you want is you want your team to be clear on their shared vision and objectives. So regardless of what people do in the team, whether developers, whether they're testers, whether operations people, whether they're architects, whether they're part of security, everybody's working together for that shared vision and that shared mission, so to speak. So the team would have some sort of mission, i.e. what are we doing and why are we doing these things? And so it's important that we all pull together. Clearly, developers' primary responsibility will be to write code. Testers will be to test the code. But generally in a DevOps culture, we want to share those responsibilities. So if we find that there's a gap in terms of responsibility or skill, we want someone to what we call bridge. That's something we talk about in the Western model, and it effectively means someone is willing to bridge that gap of skill or that gap of capability and learn something new. The only caveat to that is people have to be confident that they feel they can do that in a safe way, so they're not compromising safety anymore. So they have to have a level of training that means they're able to learn that new thing, and they have an element of competence. Generally in IT, most people are what I would call very highly skilled in lots of different disciplines, and so it makes sense for different people to do that bridging. Hopefully that sort of helps. That was a very long answer, but the sentence was everyone must consider having a shared responsibility for the for the outcomes of the team, if that makes sense, and ultimately the agile release train. That's probably the sentence. Thanks, Steve.
Thanks, Paul. We'll just do one more question. And like I said, I'll send the question out to Paul and I'll respond to all of the questions that have been asked today. I'll just touch on one and then do another. Sorry. Can we, with the DevOps 2019 report, I will send that along with that to everyone after this this webinar. The question here is from an anonymous attendee. Is the third way same as continuity plan?
Great question. So thank you, anonymous person, for asking that. No, I guess a business continuity plan is really an idea of how you're going to continue business in the event of a disruption. So the COVID-19, I guess that's why you're asking, is a great example. The third way really is a practice that, like I said, it really encourages experimentation. So as part of our business continuity planning, we should be running simulations, ideally before the adverse event, to understand what the plans and the strategy that we have in place. So strategy is pretty much, if we have this event, what are we going to do and how do we think it's going to play out? And very much the plan is then how do we execute on implementing that strategy. So for example, as a state emergency service volunteer, we do mass casualty evacuations. So we practice those. We practice those every 2 to 3 months. And we don't have a documented plan. We do have a lot to do. So training is documented. We have checklists, and that tends to be how we work in emergency services. And we have a very, I'll just pause there. I can see the internet was unstable there. So in emergency services, we have a series of checklists. We try and avoid writing a lot of documentation when in the field. However, there are areas of the SES to do with the leadership that will document decisions and those things. But certainly at the lower level, where we're executing on a plan, we expect everyone to understand what we're doing. And we want to try and talk about outcomes. What outcomes do we want? If we want to restore files, for example, what does that outcome look like? And do people know how to do that? Are they sufficiently trained to know what tools to use? And that's all part of our simulation. So the quick answer is no, it's different, but you can apply the third way very much to business continuity strategy and business continuity planning. Hopefully that answers your question.
Great. Great. Thanks, Paul, and thanks everyone for the questions. I think we'll need to move over to the demo now, and I'll come back at the end of that. Thanks.
Fantastic, Kylie. So let's move on to the demo. Let me just come out of the PowerPoint. I'll just come out of there. And to the new share now. And now we're on to hopefully my web browser. And then, so that's the State of DevOps report. And this is actually DevOps. So let me just refresh my screen, guys. What I'll do, I will pause between, oh, don't have a moment. It's thinking about it. No, we're good. So first thing we would need to do in Azure DevOps is create an organization. I've created an organization called ALC Training. After we've done that, we need to work out what projects we're working on. So I've created 2. I've created one called Vanilla Initiative. I've just clicked on that. And on the left-hand side, you'll see a number of different features, effectively, of the tool. Now, I'll quickly run you through them. We have a summary about this project, some project stats, and who's a member. The first thing you may wish to do in your project settings down the bottom left there is to go in and add the appropriate members to your initiative. We can also do the same. If I go back one, we can also do the same in our organization. So down the bottom left, I've got organization settings. I could go in here and I can assign my users in here. Best practice though is always to add your users into groups and then go back into the initiative. That's probably one of the first things you want to do. So that's how you create an organization, you create some projects, and then let me click on that again, you effectively then add your members. You can also give various rights to those people. So we can go in permissions, project settings, permissions. You can see that I've got a vanilla team here. I can click on there and you can see the permissions that I can give. So these are just the out-of-the-box permissions, but I can change them. I can say delete pre and project, allow or deny, not set. That's a quick overview. Again, it's something for you to play with once you get into the tool. Let's get into the tool, because I know you are dying to see what this looks like. Let me go in. It's running a tiny bit slow. That might be the streaming. We then got some dashboards which give us some visualizations of what we can do. This one doesn't have any. And then we have a wiki. Now let me flick to the populated safe initiative. So I put some data in here for you so we can see some real things. So straight away about my project, I've got a README file, readme.md. So if you guys are familiar with GitHub, you'll be familiar with README files. And it's just a sample README file I've put in there purely so you can see what's in my repository. I then have a dashboard. And I think on this one, I've added a widget around how many stories that I've completed. And you can see I haven't really done a lot. I've got no burn down because I haven't actually moved anything through my Kanban. I haven't completed any work. I've also got a wiki where I can share knowledge. Here we are. This is my first wiki that will help you get up to speed with a project. And there's some R code. So I'm an R developer. Anyway, boards is really important. This is where we create all our work items. In this particular view, I've moved to what we call the Agile view. Very quickly, oh, wrong button. Let's go back very quickly. In here, you can change. This is running very slow, I'm afraid, guys. Where are we? You can change the way that you set up your projects. So here, for example, you see at the top under project configuration, go to the process customize page. If I go to that page, it knocks me down to boards and process. It will refresh in a minute, hopefully. If it doesn't, I'll talk you through what you should see. It's loading at the moment. Here is where you can select your taxonomy. So you'll start off with a very simple taxonomy. It'll be a basic one, and it will have probably 3 types of artifacts you can use. I'm using the Agile one. So if I go back into my LC training and my safe initiative, and I pull up the boards again, and go into boards, and then, sorry, work items, and then click up a work item, you'll see I get a range of things I can choose from. New work item. See all these things? I can choose a bug, an epic, a feature, an issue, a task, test case, user story. We don't have time to go through the definitions of those, but there's some really good definitions in Scaled Agile. Very simply then, we can commit code into our repository. So there's 2 ways we can do that. We can use the repo here. So this is using Git, and I've got a README file as an example. You can perform commits from the repo. You can see I've done a few things there. I can push code. Again, beyond the scope of this to talk about what these things mean, but if you're a developer and you're used to GitHub, you'll already understand. It talks about the branches. I have 0 legacy branch, and I have a production master branch, and some tags I can assign. Now, where the magic really happens is in pipelines. This is how I create a build. So I'm going to give you a bit of a demo. You can see there's a few pipelines here I've done before. So let me just quickly create a new pipeline. I can select GitHub, public GitHub in this sense, or I can do a private one. So this is my public GitHub repository. I'm going to pick a pipelines-java fork. Basically, I'll fork this from another project. I'll show you where the documentation is in a moment. You basically Google DevOps Azure Pipelines Quick Starts, and that will get you to these quick starts. I can click on Maven to build this. It creates what's called a YAML file, and basically that explains how my image is to be built. And when I save and run, it will build a VM image using the latest Ubuntu operating system. So I do save and run, and then I'll show you what I get. I'll clicked on Create Pipeline. And what that will do, it will use Maven. It will take the source code from GitHub. It will then use Maven to build that project. It will then deploy onto a serverless virtual machine. That simply means it's a virtual machine you can't control. This is the job now running up. Hopefully it might do some things in front of your eyes. We'll give that a few moments. And once that's deployed, we then have a virtual machine that's deployed in Azure DevOps. Assuming we do one job at a time, we do it sequentially, there's no charge for Azure DevOps up to 18,000 minutes. So you can run a single job that consumes 80,000 minutes, and there's no, I think it's 18,000, just double check, guys, before you get charged. So If you're running parallel jobs, then the pricing might kick in. So just be careful. Run one job at a time, guys. You can see it's thinking about things. It's not doing a lot at the moment. We might come back to that. Fortunately, here's one I prepared earlier. You can see that's working just now. It's working a little bit slow. But I have an example here of something I've deployed to master. The job of success. I can click on the job itself. You can see here some of the information as it built. So this is what you would see if you were to watch the job. The other job's running a bit slow. My job is then finalized and it's successful. I can now go into, come back. I can now go into my project settings. I can now go into something called agent pools. And I can also then see how many agents are running, how many virtual machines I've got running. So I should just have one. If I click on Azure Pipelines, that's the pipeline is executed. Agents, hosted agent, I only have one. It was last run 3 hours ago because I did a bit of a test this morning. It's currently idle because the job is waiting on something on the back end to build, and it will build automatically. You can also then use pipelines, then create a state or use push to any, so use any code base. There's a list of approved code bases: Python, PHP, Java, .NET, and you can release to any platform. You can release to a private cloud. You can release to Azure, Amazon. So it's not necessarily restricted to Azure. So if I was to create a pipeline here, I can create basically a trigger. I'll quick stage one. I can then talk to which artifacts I want. So I've only got a limited set of artifacts there. I can click on create, and then it will allow me to tailor that release pipeline. Excellent. Does that make sense, guys? That was a bit of a whirlwind tour, wasn't it? Kylie, do we have any time for questions, or are we done?
Unfortunately, we don't have time for questions, Paul. We're out of time. But that's okay. Like I said, I'll send them to you, and I'll send them out to everyone early next week. So once again, thank you, Paul, for that very informative presentation. And thanks, everyone, for coming on board today. Just let you know that your points, along with any links and the recording, any related documents, will be emailed to you early next week. The recording of this will be uploaded behind the membership wall on our website. So again, wait until early next week for that to go up. Once the email goes out to you, you should be able to access that through your membership wall. So yes, like I said, please check out our future webinars that are coming up in the next few months. And please stay safe, look after yourselves and look after each other. Yeah, use your hand sanitizer. Nice one, Paul. And thank you again. Thanks, Paul. And I'll call you after this and just to touch base. So again, thank you, everybody. And apologies if we didn't get to all the questions, but you will have them answered. Take care and have a great day.
Take care, guys.
Bye-bye.